Good morning and welcome everyone. I'm Tori McClendon with NASA Communications. Thank you so much for joining us today for the joint media conference with NASA, the German Aerospace Center known as DLR, and the Alfred Wegener Institute to give you all a behind the scenes look at some very exciting plant research taking place at a test facility in Antarctica known as EDEN ISS. Here to tell you more and introduce our subject matter experts is our host, Falk Dembowski. Falk?
Thank you very much, Laurie. And good morning to America and good afternoon to Europe and especially good afternoon to Antarctica. And a warm welcome to our joint press conference about the EDEN ISS Antarctic greenhouse today. Since 2018, the EDEN ISS greenhouse of the German Aerospace Center, DLR, has been located in Antarctica near the Neumayer III Antarctic Station, which is operated by the Alfred Wegener Institute. On the southernmost continent, vegetables, salads, herbs are growing even in the polar night. This year, DLR and NASA have begun a new Antarctic greenhouse mission together. Until 2022, plant scientist Jess Bunchek from the NASA's Kennedy Space Center will research vegetable cultivation techniques for the use on the Moon and Mars at EDEN ISS. With this, she is part of the 10-person overwintering crew on Neumayer III station. So in the next hour, we will speak about what will be investigated in this research here down in Antarctica and what is happening already now. For this, for having a deep look into this amazing project, we have with us today from Bremen, Germany, Dr. Daniel Schubert, who is a project leader of EDEN ISS and from the DLR Institute of Space Systems, and from Florida, United States, we have with us Dr. Ray Wheeler, who is a plant physiologist from the NASA Kennedy Space Center, and especially from Antarctica, we have with us today Jess Bunchek, who is NASA guest scientist at DLR's EDEN ISS greenhouse, and as well from Germany, from Bremerhaven, we have with us Dr. Tim Heitland, who is a medical coordinator and field operation manager at the Alfred Wegener Institute and a former overwinterer at Neumayer III station. And now, for a first introduction and overview, I hand over to Daniel Schubert, who is located today in the EDEN ISS Mission Control Center at DLR in Bremen. Daniel, we are looking forward to your introduction and overview.
Thank you very much, Falk. Let me share my screen. I hope you can see it. Small feedback, if you can see it.
Yes, it's working.
Perfect. Good. All right. So let me give you a brief overview of the EDEN ISS analog testing of plant cultivation technologies for space. Our final goal for human exploration into the solar system is that we want to establish outposts on Moon and Mars. This is a little bit of a final goal where we want to go within human exploration. Within those habitats, we will have most likely greenhouse modules. Question is, why do we take greenhouse modules with us? Why do we cultivate plants when we are on another planet? The first reason, of course, most obvious, is fresh food. We can generate fresh food with a greenhouse. But we can also use the plants for air atmosphere revitalization. So we can generate oxygen, we can fixate the carbon dioxide of the astronauts. Furthermore, we can use the plants to use them as some sort of recycling facilities or recycling machines. We are pre-processing the urine, we're generating nutrient solution, and we give them to the plants. The plants are evaporating the water into the cabin, and we can extract that from the greenhouse and give it back to the astronauts as potable water. And last but not least, especially if you consider long duration space flights to Mars and back, that can go up to 3 years, we have some sort of well-being factor. So keeping the astronauts psychological fit is very important for those kind of missions. So those are the 4 reasons why we will take crops with us. The EDEN ISS project was formerly a European research project, a Horizon 2020 project, with 14 partners from 8 different countries. And we had an analog mission in Antarctica in the year 2018. After that, we had 2 Delta missions together with the DLR and ARBI in 2019 and 2020. So the question is, why do we go to Antarctica? Why do we test the system in such an extreme environment? Well, the idea is that we have similar challenges to Moon and Mars, or a similar situation than on Moon and Mars. First of all, the crew size of the Neumayer station, the overwintering crew are 9 people, and that is similar to what we have foreseen when we want to go to Mars, where we have right now a crew size of 6 people foreseen. Then we have a high isolation. So the people there live for several months completely isolated. They only receive once a year a resupply. So they really rely on food that they can produce on site. So there's no fresh food after a couple of months into the isolation. Then we have a harsh environment. We have sometimes temperatures that can go down to minus 40 degrees. We have darkness for several weeks. So all those kind of parameters are really also relatively similar to Moon and Mars. Technology dependency. The people are really dependent on technology. If something breaks, they have to repair it. So those are the reasons that are relatively similar or similar challenges to Moon and Mars. This is the greenhouse. This is the EDEN ISS research facility. It's a completely isolated 2 20-foot containers connected to each other. We have a total growth area of around 12 meters, and it's a semi-closed loop system. So how does the system look like? So when you come in into the airlock system here, the people can change their clothes, can put on their lab coats. From there, they can enter the so-called service section. Here are all the different subsystems that you need for cultivating the crops. And from there, you come through another door into the so-called future exploration greenhouse, or the FEG. Within the FEG, we are implementing 3 different technologies for cultivating the plants. First of all, we have artificial light. So we have water-cooled LED lamps. We are using soilless irrigation methods. So basically the crops or the roots are hanging in the air, and we spray the roots with a nutrient solution every 5 minutes. We call that method aeroponics. And we control the atmosphere around the crops. So we are injecting CO2 into the atmosphere. We're controlling the humidity and the temperature. Yes, we're very happy to have this collaboration mission with NASA. First time that we have this joint mission to Antarctica. We have worked out in the last months a very multifaceted science program. First, we're looking into crew time and handling procedures. So how much time do we need to produce the crops? We're looking into food quality tests. So is it safe to eat the food? We're looking into microbiology. So what else is growing in the system besides the crops? And we're looking into the psychological impact that plants have towards the crew by consumption of the crops or just by treating the crops. Last slide from my side. DLR is, of course, going forward in its ambition for a planetary surface greenhouse. And we have just announced a roadmap, a 10-year roadmap, to develop a test demonstrator that you can see here for the moon surface. This is our greenhouse system. It will be built by 2025, and then we will have a test phase for a couple of years, so that we think that in 2030, we will have a ready-to-use design for building such a system. And with that, thank you very much for your attention.
Yes, thank you very much, Daniel, for this insights. And now we are looking on the NASA part of this joint Antarctic mission. And for this, we switch now to Ray Wheeler. Is Ray with us?
Yes, I am.
So
good morning to North America, US, and good afternoon to Germany and Europe, and also Antarctica. Let me see if I can bring my slides up. Okay. Hopefully you can see them.
yes, it's okay. It's fine. Okay, seems that Ray has some connection. We will try it again a little later when we come a little bit faster to the highlight of this press conference today. So we go now to Antarctica, to Jess Bunchek, directly in the EDEN ISS greenhouse. Hello, Jess, how's it going?
Hi, Falk. It's going great. Yes, and welcome everybody. Good morning, good afternoon. May the 4th be with you, and welcome to the inside of EDEN ISS. I'm here inside the service section in particular. I wanted to start in my tour here. As Daniel had mentioned, we are tracking a lot of different kinds of science, and one of these areas is crew time. And so that involves how much time is being involved to grow the actual plants. But the service section is an incredibly component of growing plants in such an extreme environment because so many kinds of support systems are required. So crew time is not only involved for the plants, but also to just maintain any of these systems that are needed to keep plants alive in a place that, for example, today outside, it's around -16 degrees Celsius. That's just above 0 in Fahrenheit scale. And the wind outside is around 55 kilometers per hour, around 35 miles per hour. So it's a bit of an unforgiving environment. In fact, I'm going to turn you around and show you out the window here. This is actually facing north. And so on a really beautiful day, we would be able to see the Neumayer Station right about here or so, 400 meters away. And this is where I start my daily commute each and every day to get out to the container. But as you can see, it's Antarctica outside. It is very extreme to be here, and it is a beautiful place, but the weather is not, it's not beach weather, so to say. But you can see that there's a hand line outside, and so that's how we can safely navigate when we have these whiteout conditions. But looking outside, like I mentioned, it's beautiful, but we don't have a lot of stimulation for the senses. So no trees, no greenery. In fact, our day length right now is heavily decreasing. We start the polar night in just over 2 weeks. And so today we have around 5 hours of daylight, and this is the middle of the day. It's about as bright as it's gonna get. So with that, with living here for over a year, and with the majority of this being in isolation with my other crewmates, we go through a lot of sensory deprivation, which makes this kind of environment absolutely important for keeping our psychology aware. In fact, I'm going to take you now. You can see the colors, the sights, the sounds. Welcome indeed to the greenhouse portion of EDEN ISS. It is quite beautiful. And I've been here for a few months, and I can say that this is my favorite part of my day, and I find that my energy gets lifted up in here. But we can't rely just on anecdotes for quantifying the psychological benefits of working in a space like this and having fresh produce. So in addition to crew time, we're also doing psychological surveys, similar to the ones that we conduct with the astronauts on the International Space Station, to get more data on just how important it is to have fresh produce in these isolated, confined, and extreme environments. We also do a lot of crop selection testing between NASA and DLR. So really looking for crops that not only do well in these kinds of environments, the size constraints, the different temperature requirements, but they're also highly nutritious crops, particularly for key nutrients that we know astronauts could be lacking in for those longer duration spaceflight missions. And as Daniel mentioned, we do other testing for microbial and food safety analyses, because we want to make sure that anybody who's eating this produce or interacting with the systems is going to be safe in doing so. And combined between with working with these particular systems, selecting for better crops and also for better cultivation methods, this has applications not only for our space flight, but also what we are doing on the ground in controlled environment ag, such as urban agriculture, vertical farms, or greenhouses, which is a way that these are increasing for agriculture production across the world. We are also doing a lot of testing to find out how much it takes to keep a system like this running. So we work with data analysis, how much water, how much power, how much air circulation is needed to power a system like this. And so inside, we will go through a little bit of a tour later, but again, I want to welcome you to the beautiful EDEN ISS. And with that, turn it back over to Falk.
Yes, thank you, Jess. And you mentioned it already. We will come back later to you in some minutes. Amazing green in the eternal ice there down. So we do a second try with Ray at the Kennedy Space Center. I've heard that we will get his slides via DJ. Yeah, great. There we have it. So a second try for you.
Okay. Thank you, Falk. And I apologize for the technical difficulties. And The slides will be small, but they're just a few that I wanted to show. As Daniel mentioned, and he covered this very well in the introductory talk, DLR and NASA and other space agencies have been interested many years in the use of crops for life support mission applications for space. The crops provide food, but they can provide oxygen and carbon dioxide removal. And as you just heard from Jess, there's very important psychological benefits of having live green plants available to the crew. So next slide, please. So this is a picture of some of the testing that NASA has supported over the years. We had a large closed chamber that was quite similar in the planting area to the EDEN module, but it was not located in the very unique environment that EDEN is. You see that on the left, growing lettuce plants. We're also very interested in crops that fit very well into the mission needs. For example, if we're constrained in terms of the space and volume, maybe dwarf crops would fit very well. And you see a picture of some comparisons of dwarf tomatoes on the right. Next slide, please. Next slide. So where are we today? We're hoping to get to planetary surfaces like the Moon and Mars, but we do have the International Space Station, and we are indeed growing plants on the space station right now. You see a small chamber called Veggie on the left, and an astronaut, Jessica Meyer, is harvesting some Mizuna leaves from that chamber. Mizuna is a leafy green, and on the right you see astronaut Steve Swanson. He was one of the very first astronauts to test the veggies. So we're starting modestly in the International Space Station, beginning to grow foods to supplement the crew's diet. But then in the next slide, hopefully as we go farther and stay longer in space, we'll be able to set up systems on surface settings like the Moon and Mars. Here you see an artist's version of what something might look like if you have a logistics module that could be converted into a plant growing system. On the left, you see that set on Mars. And if you were to look inside, you could see maybe something like this, vertically stacked shelves of hydroponic systems. So this is very similar to the EDEN ISS module. And so I just want to say again, this is such a unique opportunity to collaborate with DLR, to be able to test these concepts in a very high, what's referred to a high fidelity setting like the Antarctic. So thank you, and I'll pass it on to the next speaker. Thank you, Falk.
Yeah, thank you, Ray, for your perspectives. And now we come to someone who knows the eternal ice and overwintering very well. Tim Heitland from the Alfred Wegener Institute in Bremerhaven will give us now some more facts and insights about overwintering at Neumayer 3 station. Tim.
Well, hello, everybody. Let me share my screen. So I'm here to give you some more insights and details about overwintering in Neumayer Station 3. Neumayer is the overwintering station of Alfred Wegener Institute for Polar Research and Marine Research that is located here in Bremerhaven in Germany. A normal overwintering, the isolation period, as Jess already said, is about 9 months, and you would have about 9 expeditioners this season. With the 41st overwintering, we have 10. Normally you got 4 scientists, and those people run the long-term observatories. Those are the meteorology, atmospheric physics, geophysics. Then you got the doctor, and he or she also doubles as the base commander, and we do run some medical studies at the station. Additional to that, we got an engineer, electrician, IT, and a chef. So those people will be there for a period of about 14 months in total, and 9 months out of those are in total isolation. Obviously, the station is located in Antarctica, and to be more precise, and now my screen is not working, now it does. It's in Trondheim, Nordland. And as pretty much everything is in the north of the continent. It's always easier to explain it like this. The part of the continent that faces Africa is Groningen-Mautland. In the upper left corner, you can see Neumayer Station, and our next neighbors would be 24,000 emperor penguins in Atka Bay. And if you would take your ski-doo and drive for 250 kilometers, then you would reach Sana E4. That's the South African overwintering station. And those are the real next neighbors that we have. That's a picture of Atka Bay, and the tiny little dot in the lower left corner of the picture, that's Neumayer Station. It's about 6 kilometers to the bay where the emperor penguin colony is, and about, as you already heard before, 400 meters to the south of the station, you would find the greenhouse. It's part of the extreme ice shelf, and an ice shelf is the part of the glacier that's floating down the continent and has just left the continent and is now floating atop the Southern Ocean like a water lily, basically. So, in fact, underneath the station, you will find ice, and then you will find water again. That's a picture of the colony and of the 24,000 individual emperor penguins, and Antarctica really is breathtaking. It's such a nice and unique and pristine place. You have landscapes that are unique and breathtaking. You have wildlife that is really beautiful. And it's really something to be there. But nevertheless, it's really a harsh environment, and I think it's safe to say that it's one of the harshest that you can find on this planet, at least. We are talking about wind speeds up to 80 knots per hour. We are talking about temperatures even of minus 50 degrees Celsius. And you got ever-changing weather situations with blowing snow, white out, and it's pretty easy to lose your way around if you don't know what you're doing. So that's also why we put a lot of effort into training our expeditioners before we deploy them south for overwintering. They will have to attend 4 months of preparation here in Bremerhaven and in the Alps, and they will run through a whole lot of courses and, for example, mountaineering course and learning how to survive on the glacier, firefighting and whatnot, a whole lot of courses to prepare them. With Garden Eden, the EDEN ISS project, the greenhouse, and now you can see the Neumayer Station in the left of the picture. That's the 400 meters that everybody's been talking about. With EDEN, we have a real asset to the station. I think the others already told all the things that are so valuable about having the crops there, and I can tell you out of my experience when overwintering, it is really possible to have daydreams of tomatoes. So with that, thanks everybody, and I give back to Falk, I guess.
Yes, thank you very much, Tim, and thank you for this very nice pictures from Antarctica. And now, before we come to all your questions in this press conference, we switch again to Antarctica. Jess and Daniel will give us a quick additional tour through the greenhouse. So Daniel and Jess, how the different plants are growing now.
Thank you, Falk. Yeah, Jess. So let's have a look. So we talked about this in the last couple of weeks, but I just wanted to know, so how is the rucola going, for example? I think you just harvested last week something, but how is it going?
Yes, so the arugula, it's right here. And this will be our second harvest. We're about to do that coming up in the next few days. But the first harvest, I have to say, I know I'm probably a little biased, but it has been the best arugula I've ever had. Just a wonderful flavor. And some of these we've allowed to go to flowering just to see if it makes the flavor a little better. And the flowers have been cool as a centerpiece for a dinner table. And even today we had some pizza. And so we've been using the last of the arugula to top of our pizza. So it's a great crop to have right now. Perfect.
And how is it with the cucumbers? I think they are coming, right? I think there are some already there ready to harvest, I think. right?
There are, yep. So actually the harvest of cucumbers will be this afternoon. And so we'll be able to have our first cucumbers tonight. And I even went ahead and harvested one of them so you can see just about how big they are. So this will actually be the first fruit that we will have the chance to eat fresh since we have left Germany in December. So it's going to be a very big celebration for us. I'm very excited for the crewmates to get to experience this too. But as you can see, the cucumber plants are behind me. And so it's wonderful to have these beautiful plants also growing in the greenhouse.
Just a quick question. Are the crops already, I mean, they are like wine crops, so they're growing on lines. Do you have to already put them down a little bit, or how is that working?
I have, yep. So actually I'll take you with me and show you a little bit closer. So the cucumbers, they start growing on the ground and then they work their way up these vines all the way up towards the ceiling, and they will continue to grow. So then once they get a little bit too tall, then we can drop them down a little bit, give them some more space to keep growing. And then once the cucumbers on the bottom are ready to be harvested, we just keep working our way up. And the same is true for some of these tomatoes that we have back here. So these are a little bit slower to grow since they're a little bushier than the cucumbers, but again, they will continue to reach the ceiling. And it's wonderful to have this wall of green here.
Do we have already tomatoes? Is it, I think some green tomatoes should be already there, or are they flowering right now?
They are doing both. So we have some tomatoes. So these are some of our dwarf orange tomatoes, the cherry tomatoes that have already been flowering. And you can hopefully see we have some fruit setting on these. Nothing has ripened up yet, but we are very excited because there are hundreds and hundreds of tomatoes already forming, and we're just getting started here.
Very nice, very nice. Good. And I think you're also near to the kohlrabi right now, right? Or is that in the I think that's
So the kohlrabi got harvested. We actually harvested the kohlrabi earlier this week, but we do have some other crops that are similar to kohlrabi. So we have broccoli and cauliflower, and this is the first time that we have grown broccoli and cauliflower inside the greenhouse. And it's very exciting because we did not expect that the cauliflower would start to put out some cauliflower heads. We thought these would just be leaves, and so that was a really fun surprise a few days ago. So it's an exciting place.
All right. And I think we are really on a good track on pepper. As you know, in our first mission, we had a little bit of difficulties to get the pepper up and running, and the harvest was not so good. But I think this year, in this season, we really have some good, those are the peppers, right?
This is it, yeah. So we have some peppers up here and then also some peppers on the one below. But I really want to showcase these particular peppers right here. These are the Espanola peppers, which come from New Mexico in the United States. So all of our chili peppers here are, we've been doing a lot of research on this back at the Kennedy Space Center. And Espanola in particular is a really exciting crop right now. This crop is being planned to go up to the International Space Station later this year and grow in the Advanced Plant Habitat Facility. And if we can do that, then that means that this would be the first fruit to officially grow in space. So it's very exciting and very wonderful to have this crop also here with us in Antarctica for research.
Perfect. Thank you very much.
You bet.
Okay, so thank you again for this additional insights. Yes, and now we come to your questions in this press conference, and we will do this in two ways. So for those of you who are in this meeting, if you want to ask a question, you have the possibility to write your name, organization, and question into the chat of this meeting. And the second opportunity or possibility is that when I ask you, you can put on your camera and raise your hand, and I will come to you, and we will change this both modes after each other. And then additionally, for the people on social media and those who are watching the YouTube live stream, you can ask questions via the hashtag Made in Antarctica and as well in the YouTube chat. So let's have a look which questions we have already. And yes, I will start with the chat. So here we have a first question, and this question says, how can I join in this research, and what classes should an engineering undergrad consider taking if they want to work projects like this? Maybe for
this
Daniel?
is for Jess. No, I think this is Jess. Because she's in Antarctica.
Jess?
Well, actually, I'm not an engineer. I'm a botanist by training, but the one thing that I have to say is definitely follow your passion. So for me to get here, it was pretty unconventional, but I just kept thinking, what dreams could I end up following, and went from there. It's really important to diversify your skills. So, for example, I took German in high school and through college and thought I just wanted to take another language and learn it. Never did I think that having learned that language would bring me here for this particular research. So as you're thinking about what to do with your undergraduate courses and your engineering courses, if this is something that you feel extremely passionate about, run with it. Absolutely run with it. But also think about some different areas and some different skills that you can do either in your classes or outside your classes that can help to diversify your skill sets. And also remember that when you are applying for things like internships or jobs, these other experiences, whether in your classes or otherwise, they can be important for making yourself sellable. So always just, remember who you are and what you individually bring to the table.
Okay, thanks. So the next question in the chat we have is, how does the EDEN system address ppm concentration in the water supply? And is this semi-closed loop system sustainable of vote?
There's also was something about Jess. Sorry, say it again.
Shall I repeat the question, Daniel?
Yes.
Okay, so maybe it's for you, it's a more technical question. How does the EDEN system address the ppm concentration in the water supply? Is this semi-closed loop system sustainable?
Yeah, so basically we have a closed loop irrigation system. We have two mixing computers that are providing the nutrient solution. We have one nutrient solution for leafy greens that have an EC value with a lower EC value. And then we have another nutrient solution also connected to the mixing computer that has a higher concentration, and that is used for the fruit building crops like cucumbers, peppers, and tomatoes. And we have a mixing computer and we have two stock solutions, A and B. And of course, we're controlling the acid and base, so the pH will also be controlled by the system. And for microbiology countermeasures, we usually use an ozone injection system. So this is basically the NDS system, the nutrient delivery system.
Okay, great. So and then another question, a little bit shorter. How is zero-G affecting the growth of the plants? So you don't have zero-G in Antarctica, but maybe...
That's for Ray, I would say.
So also
well, and Jess has experience working with the veggie unit.
True, correct.
But yes, that's a good question. Clearly on Earth, we have gravity, so conventional hydroponic systems, aeroponic systems work. The water drains, you can manage it and pump it around. But in microgravity or weightlessness, there is no up, there is no down, so water doesn't drain. And so this is a challenge, and it has been for many years, of how to supply water to plant roots in space. And then also not get them too wet, so they suffer from not getting enough oxygen, hypoxia. So these are ongoing challenges, but there have been some pretty good solutions, and we continue to do research on this. But you need to contain the water. Yes, good question.
All right. So, and then we have the question, why was the EDEN ISS greenhouse located 400 meters away? It doesn't seem like much, but I'm sure.
This is for Tim, I would say.
So Tim, why is it so far away from Neumayer and not directly beside?
Yeah, I think there are several reasons for that. First of all, there is limited space available in the station, and that's really a problem, because the station was not planned for hosting a greenhouse within. But I think that plays to the advantage of this kind of science that you're conducting there, because the whole crew time thing is valuable to get to know how long does it take to dress up, how does it affect the people that they have to leave in no matter what conditions, and so on. And besides that, we have even more of the long-term observatories outside of the station, located outside of the station.
Right. So yeah, then we maybe put in also a social media question. I've mentioned this, that we're also doing this in this press conference. So I just have a look at this, and there we have a question from Instagram, and this question is about that someone would like to know in crops that are cultivated this way contain if they contain the same minerals and nutrients as those that have grown under sunlight and in natural soil.
This is for Jess. That is for Jess, I would say.
Yes.
I don't know.
Yeah, I can take that one.
Yes.
We actually are particularly targeting some crops in here that we have done research on in other environments. So a lot of these crops could be have research at the Kennedy Space Center, or a few of these have also been crops that have been grown in space. But a lot of the crop candidates that end up being selected to even get to these places to begin with go through a long process of crop selection. And the crop selection has been based on trial and error. So really whittling down a lot of new candidates that could work well in these systems, but also relying on literature. So with what other research has been done in other environments. So it really is just building upon a community of knowledge to try and think about how these plants grow not only in this particular environment, but also how they compare to other environments, because ultimately this may or may not be the best solution for going to Mars, but this is why we do science, is to test things and to find out what works, what doesn't work, and find the best option for moving forward, and then continue to ask these questions over and over again until we can get everything right.
Right. Good. So then we now change to the other mode that I ask who wants to ask a question directly here. And for this, please give me a sign. Put your camera on and give me a sign. And
Falk, it looks like we have Julian Sanction.
Yes. For GQ UK, thank you very much. I would love to know a little bit more about what the you expect the psychological benefits of growing plants would be. Some might be known, but especially in the context of isolated and given the harsh environments that you'll be dealing with, some of these will be determined by the surveys. But what do you expect these surveys to say in terms of the psychological benefits of growing plants?
I can take this one. Yeah, we know from previous literature that plants do have a positive effect on the psyche, and this has become especially true over the last, well, now over a year with the pandemic, where a lot of people have been taking to purchasing more plants or gardening because it is such a wonderful psychological benefit. But apart from this kind of analysis where it's more anecdotal, we are really trying to do a more quantifiable method of looking at the psychological benefits. So part of this is pairing these questions with the amount of crew time that is being spent by not only myself, but other individuals of this team who come out to do activities, whether that is scheduled activities, so working, or if they are coming out just to enjoy being with the plants. And we also ask them about not only what kind of interactions they have with the plants, but also if they're in the station, just knowing that there are other living organisms out here, what that could potentially be providing for them. So with having these questions asked before we arrive in Antarctica, and then we ask these questions monthly throughout our time that we are here, and these are paired with our other medical studies that are being conducted that we also do each month. And then we'll also do a comparison at the end of our overwintering. So once we have returned to Germany, then we can look over time and see if these results will change. So the quantifiable numbers, if they will change. And some of these things that we are looking at are ratings, so how much we enjoy these activities, but also how these activities make us either excited or not excited to be able to consume or touch or work with the produce after they have been harvested.
Okay, thank you. So I think the next is Teresa with a question. Oh, you have to unmute yourself that we can hear you.
Hello. So my question is, how many such greenhouses would you need to fully sustain a crew on Mars, on Moon? What are the major technical challenges of replicating such a greenhouse on the Mars or on the Moon? And are there any plans to actually grow kind of animal-based proteins, either like lab-grown meat or, let's say, actual animals in such environments?
Yeah,
I can take a start at this if you want.
yes, Ray, go on.
So for a number of years, these same questions have been asked, and there's various ways you can do this sort of analysis. A common way is to say, how much growing area do we need to provide the dietary energy? Maybe you say 2,500 kilocalories per person per day. And so the studies that various groups have done, when you grow plants with high light intensity, and light intensity is important, the more light you give the plants, the more they grow, the more they produce. A number of something like 40 to 50 square meters per person would support them with pushing the plants very hard. But that's a very, you might say, just macronutrient diet, carbohydrate, protein, fat, so you maybe won't get all the micronutrients. So there's different ways to think about this. If you have less light and more volume, it's a continuous kind of economic analysis and trade study, you might say, of how you go about doing this. But we have those kinds of numbers. And then if you think in terms of just providing the oxygen, it's only about half that area, 20 to 25 square meters. And that's because you get enough oxygen, you get that from all of the plant biomass, but you don't get to eat all the plant biomass. So I hope that answered some of your question.
Okay. Thank you very much, Ray. Just a hint, if you ask questions, it would be great if you could always say your name and your organization, where you're from, also in the chat. And is there another one who wants to ask directly a question before we change again to the chat mode?
Well, I had a couple of, there were two other questions which I don't know what anybody else would like to answer, and that's the animal-based protein and what are the major technical challenges of replicating this in actual like Moon or Mars environment.
Yes, I forgot you asked those. So I'll continue, but others please jump in. So yes, excellent question. For example, what do you do with the inedible plant leaves and stems? And so this has been considered for a long time. People have done studies where they feed them to fish. And most recently, groups in Japan and China are exploring feeding them to insects. So you can recover, you might say, some food from this inedible plant, what might be considered waste. So there are ways of generating, of recovering some food using sort of secondary consumers of the inedible biomass. And if you choose the right organisms, maybe you get high value food. Same with fungi, mushrooms and fungi. Maybe you can use them as well.
Then I have again a question from social media, or better the YouTube chat, and it's a special question. It's from your brother Jess, with some greetings from him. He asks, are all of the planets being grown strictly being used as food, or are there and other plants being grown for other reasons? Soil reconditioning, psychological improvement, anything besides lunch?
Well, hi. At this point, we're really focusing on having the pick and eat crops. So we are focusing on how much edible biomass can we have, either to form part of our meal or a majority of our different meals. We do sometimes get to have some other benefits. This is really great to have other crew members come in, because I look at this place very scientifically, and they can come in and think, oh, well, we could take, for example, like the flowers from the arugula, and how do we then turn that into a centerpiece for our table? So how do we use that more recreationally? But in this particular space, we are not focused on growing, at least at this time, at growing plants for more of ornamental use. So anything that we have that's not being used for science or not being used for our table decorations, we are trying to be very conscientious about having a lot of edible biomass and a little amount of biomass that we can't use.
All right. Thank you, Jess, for the special answer. Okay, so then we switch back to the chat, and here we have a question of Frederick Eager. He's reporting for Interplanetary TV, and he wants to know what are the 20 crops mentioned by one of your scientists that are being grown in EDEN ISS besides leafy greens, radish, tomatoes, cucumbers, and peppers. What any heavy there? Also, what's also there?
You mean what else we grow?
Herbs.
Yeah.
Go ahead, Jess. Go ahead.
We do also have herbs right now. We have basil, mint, and parsley growing, but we also do have some new crops to try this year. So as I mentioned, broccoli and cauliflower are new ones. Some of these pepper varieties are new ones, but we're also getting ready to hopefully try working with peas and beans. So those are crops that have not been grown here before, but will hopefully be good candidates for this kind of system.
All right. And then he asks as well, additionally, if you have also considered diversifying, legume and high protein legume and vegetables. So I have some other, I think, suggestions for you. So like spinach, broccoli, potatoes, sweet potatoes, cherry moyas, mulberries, blackberries, nectarines. So yeah, have you thought about other things as well before the mission?
We have. So with looking at diversifying the legumes, the peas and the beans are a couple examples of those. Ray has example having worked with potatoes in his research. So Ray, do you want to talk a little bit about having worked with those?
Yeah.
So in this direction, the question goes, yeah, Ray.
Okay, yeah. So yeah, I think for longer duration studies, people have tended to think more about field and agronomic crops, things like wheat and potatoes and rice and so forth. And so yes, there have been some studies, and you can even grow them hydroponically in things like aeroponic systems. So that's an encouraging observation. It's with regard to things that produce woody trunks and stems like small fruit trees, raspberries. That's a new area that's of interest. If we can get the plants small enough and deal with issues of dormancy, then that could be a possibility for future crops as well. Yeah.
So basically, let me quickly add to that question. So here at the DLR, we are looking into a hybrid food strategy for the midterm scenario. So meaning we will produce the fresh crops like high water content crops, like we already have now in the EDEN ISS container, directly on site, on the moon, on the Martian surface. And we will take stuff like rice, wheat, corn, even potato powder with us, because that you can really store very easily. There is no cold chain that you have to keep in mind. You don't have to freeze it. It's very easy to transport that. So we will bring that stuff from Earth, and then we will combine it with the fresh produce on site to ready-to-eat meal.
All right. Thanks, Daniel. So then we switch to the next one here. We have Julian Sanction from GQ UK, and he would like to know, could you please tell us more about the psychological benefits of growing plants separately from the nutritional benefits? So the psychological part.
Sorry, that was already answered, it seems. I'd asked that in person.
Okay, so yeah. Sorry.
Thank you.
Switch over this one.
We have a question from the Q&A, if you don't mind.
Yes, why not, Lori? Tori?
Okay, the question is, how do you transport the fresh produce to the habitat?
So there are a couple different ways that we can do that. If it is a pretty small crop, we have some weatherproof backpacks that these can be safely stored inside science containers and then put into the backpacks to keep them preserved when we do leave the greenhouse. For any of our larger harvests, we do have specialized coolers that can help to keep the plants we're not trying to keep them cool, we're actually just trying to keep them relatively happy while they're being transported back and forth between here and the station. And anything that we can't carry with us on foot, we have to take back and forth on sleds, with the exception of very large things that can be brought out by some heavier equipment. But it's all very much human powered here.
And maybe I could add to that. The thing is that the EDEN ISS container is directly on the way to the atmospheric physics lab that is outside of the station, 1.5 kilometers to the south. And you cannot take any combustible engine powered vehicles in this direction, because then you would run the risk to measure black carbon and whatnot that is produced by said combustible engines. So Jess, unfortunately, has to carry all supplies by foot and in a backpack.
All right, good. Then we go to the next question from Ose Kicker. It's from German newspaper, Nordsee Zeitung, and she wants to know, do you test strawberries too? We had been before, Daniel, I guess.
Yes, we tried. We had some difficulties with the strawberries. They had a lot of flowers, and our former gardener Paul Zabel, he also did the pollination and everything. So he played the bee, but it was not working, unfortunately. I think we still have a couple of seeds, but as far as of now, we have not yet planted. What, Jess? What do you think?
That's correct. I'm both.
Right. And then we have a question here from the German TV broadcaster ZDF, from Lisa Miebach, and she wants to know, you mentioned that this is the kickoff of a new research mission period at EDEN. What are the exit goals for the new period? When and what was the most recent big milestone?
So basically, we're now in the fourth mission, basically in Antarctica, together with Jess and NASA. So this is for us. First of all, it's a big milestone for us to start our international collaboration towards the US. We already had research partners at the University of Florida for that, but now we're broadening. They are still there. They are still also with us, but we are now broadening up everything together with NASA. Nevertheless, what are the big milestones that we are heading for? Is that the question? So what are the future goals a little bit? Did I understand that correct?
Correct, yeah. Mm-hmm.
Yeah. So as I said, with the roadmap that I mentioned in my presentation, so this is the big goal where we want to. So all the lessons learned that we're doing right now in Antarctica, we want to transfer into a space-ready design for Moon or Mars. So this is a little bit what we're heading to within the next 5 years. But we're also looking into applications with respect to big data applications to do some sort of risk mitigation applications inside the container. We are working on the development of a robotic arm that can basically, with artificial intelligence, let's say harvest cucumbers or treat the plants, cut leaves away, things like that. So those are also a little bit of the milestones that we are looking in for the next couple of years.
All right. Thanks, Daniel. So again, I look to social media, and there we have on Twitter a question, and this is, are the different gas concentrations also be measured in the system to explore a use contribution to create breathable air? Is this a part of the research in some way?
Well, we are not looking into, we know that the plants are producing oxygen. That's for sure. We can actually see that in our mission control center very nicely on the graphs. but we're not using that in that sense. So we're not, let's say, capturing the oxygen and breathing it in the station or so. No, that's not what we're doing. We're measuring it, and it goes into our resource and benefits calculations, but we are not using it in that sense. That would be too complicated.
Good. Something to add from you, Ray, or was this the answer?
Renee? Yes, we've got another question, which is, what is the total power consumption of the EDEN system per year, and how much potential food does that produce per person?
That is still something that we are looking into. It differs a little bit, or it depends a little bit on the outside climate, of course. If we have a very cold winter, of course, we have to heat more. And that we had, for example, last year, it was very, very cold. So in that sense, you cannot really, let's say the climate situation is not so stable as we will have, let's say, on the moon, where we can relatively easily predict that. Nevertheless, the total energy consumption for a whole year, I have to look it up, to be honest. Power consumption, we are in the range, as I said, depending on the climate and the weather conditions, but it is roughly between 7 and 9 kilowatt.
All right. Good. Then maybe I switch again to the mode that you can raise your hand and put on your camera if there is maybe, again, someone who wants to ask directly a question to the panelists. But if not, it's also fine. Then I can just go on with the chat. Oh, there's someone. Bruce Link.
Sorry, I got to unmute. So really a question for Jess, and I'm a colleague of hers at Kennedy Space Center. And it hadn't really occurred to me until she was talking about maybe taking some of the vegetables for experiments. Does that cause any stress to the people who are looking forward to eating them? Because we think a lot about how the plants are helpful to the people growing them, but is taking them for experiments causing stress to the rest of the crew?
Short answer, no, for a couple of reasons. The first is that with the help of the scientists back at the Space Center and also the DLR scientists involved, we did a lot of planning ahead of time to make sure that we can still get our science samples without taking a large portion of the different crops. So it helps to benefit from both ways. And so it's not only that we're taking a sample size from each crop that can work for the science and leave enough for the crew, but also the number of crops at any time that we are testing is also pretty variable. And the second reason is that EDEN is, I wish I could knock on wood right now, but EDEN's running really well. And so we actually have a lot of produce that we can harvest. And so even with doing our science sampling, the crew is still having more than enough to eat, which is wonderful.
Great, thank you. Wonderful to see you.
You too, Bruce.
Thank you. Good. Then, I go on with the chat. There we have the question from Talon, USF. How does the performance of EDEN's aeroponics compare to other technologies such as veggie or APH?
This is something that we are trying also to figure out with this campaign, because the EDEN ISS is solely based on an aeroponics system. And for veggie, and that can Jess and Ray perhaps say, they use a different system. Perhaps, Jess, you want to talk, because you worked on the veggie system, correct?
Sure, yeah. One big difference that we have between the aeroponics system here and what we have on the International Space Station right now is that the aeroponics system is a truly soilless system, whereas in space we are working with different kinds of containers that are filled with a clay-like media, and this helps to control the water a little bit better. As Ray had mentioned, water is a big challenge that we work with in space. So as we are thinking forward, how can we move to they're already soilless, but how can we move to a method that is more relatable to the aeroponics or hydroponics system? Another big difference is that the advanced plant habitat is more automated, whereas veggie is a more involved system. So the astronauts do go and do a lot more hands-on activities, not only with starting and finishing the experiments, but also with doing daily checks and manually watering the plants. Whereas in our aeroponics system here, I also do daily checks and maintenance, but fortunately I do not have to water all of these plants myself.
All right. So then the next question I've here, it's beyond the physical, psychological benefits. I have read that the radiation in space would slowly destroy the vitamins and the pre-packed food supply on a mission to Mars. Does NASA have an estimate of how big a space greenhouse would need to be to make up for those lost vitamins and nutrients? Ray, question to NASA.
Well, I'm not sure we have the right members on the panel to ask that. We need food scientists. But yes, I've heard similar concerns expressed about, radiation and the space environment in general on stored foods. And we know that certain vitamins do degrade with time. It's just you might say, a shelf life kind of phenomenon. Things like vitamin C, vitamin B1, and so forth. So we are thinking about those things when you select the types of crops. The effects of radiation directly is still an area that needs further research, is my assessment right now, and not only just for the food, but for the plants and of course the humans, the most important things. So how do you prevent, how do you shield things, what are the radiation tolerance limits, and so forth. So that's an area that we're still need active research.
All right.
Interject before we go to the next question. We probably have time for one more question, maybe two.
Yeah, maybe two. So yeah, the time is running. Sorry, you're right. The time is running.
I have time. No problem.
Maybe you can make have 5 minutes more, but yes, you're right. The last questions, maybe 3 or 4 we have still. So let's see. So what we have here in the chat is another one. And this question is, yes, from Daniela Seta, and she wants to know, what is the current nutrient source of the fertilizer?
Basically minerals, but as Jess is mixing all the nutrients, I refer to Jess for that.
We have 2 different kinds of nutrient solutions that we'll use for the crops based on their growth habits. So we have one that is tailored more towards our leafy greens and one that is tailored more towards our fruiting crops, since they have a longer life cycle and will have some different nutrient requirements. But as Daniel mentioned, we actually make up everything during the summer season. So we do a lot of preparations during the summer season, which here is, for us particularly this year, it was from January until the middle of March. And so then in our nutrient delivery system, when our stock solutions of these fertilizer concentrations gets low, then we just bring out more of these pre-measured minerals that are going to be targeting the macro and micronutrients of the plants, and we can make up more nutrient solution as we need to for the different crops in here.
All right. And then I have again a question from the YouTube chat, which we can combine with another question here in the chat. And this is, what is the total power consumption of the EDEN system per year, and how much potential food does that produce per person?
That we had already. But for the 300.
One thing from YouTube, they want to know where does the energy comes on Mars from? So from
where the energy comes on Mars? Well, well, different sources. But Ray, I don't know.
Yeah, that's a big challenge. Right now, most systems they would include some solar. The small rovers and things like that actually use what are called RTG. They're radioactive thermal decay power generating systems. So they are kind of small in terms of total power, 500 watts, 700 watts. But NASA and perhaps other space agencies are actually beginning to think of fission nuclear power systems that can be smaller in size, tens of kilowatts instead of megawatt size things. So this is an active area of research and a very important one, because we will definitely need power when you get there. Yeah.
Okay. Good. So then we are at the point for the last question. Is there someone who would like to ask a last question directly with the
We have
camera?
someone on camera. I believe it's Jillian again. Jillian Sanction.
Yes, I was curious, since now you have something to compare it with, and maybe this is a question for Jess again. What was it like before you had fresh vegetables to eat? I mean, what kind of did you feel a sense of satiation, of monotony, or did you feel physically unwell? I mean, what is this concretely? How does this change life for you?
Personally, I don't really know if I was feeling any of the monotony. All of our food that comes here to Neumayer, it's going to be frozen, or it will be stored in very dry environments. So, for example, we do have fruits and vegetables, but they are all frozen. So there were some things like any of the salad crops, things that you have to have fresh and just would not freeze well, that we had not had the chance to have for a while. So I really personally hadn't noticed the day-to-day changing in how I was feeling, but I could say that there's been a lot of excitement, especially because it's early in the overwintering, and so we haven't had a lot of these particular crops to eat yet, like the cucumbers, for example. And so when I get to say, okay, like we're getting really close to this particular harvest, there's a big excitement that comes up in our entire group of wanting to get out here and see the plants and help with harvest, and then a lot of excitement around getting to eat them. I can say anecdotally that when we did have our first harvest of the salad greens, it was interesting how I noticed I reacted, since I work in here and touch the plants with gloves all the time. I found that I was just touching the leaves before I ate them, smelling them a lot, and really enjoying having that flavor. I think without not only just not having eaten them for a few months, but also not having seen these plants even in a grocery store for a few months, I wouldn't really think lettuce could be so exciting, but it really was.
Yes.
Maybe if I could add, like my overwintering was the last one without the greenhouse, and I do recall that it does actually make you really happy. It really is just a feeling of happiness to get the fresh crops and whatnot. And the first plane that resupplied the station, when the first people were flying through, and that's just anecdotally, so we unpacked the plane and they had salad for us. And everybody was getting out of bed, and we had a big salad party without even dressing on the salad at 3 in the middle of the night, because we've all been so hyped about biting into the leaves of salad. Yeah.
I'm so sorry, Tim, that I couldn't come earlier. 1 year. It was only by 1 year. Sorry.
What was final
It was okay. It's okay then.
From Tim about this amazing green down there in Antarctica. So I think we are at the end. Thank you very much for being with us today down in Antarctica at this joint press conference of DLR and NASA. And thank you for all your questions. And for those of you we had not the time to answer your questions now, please write us, and we will try to answer all your open questions also after this press conference. Thank you very much, and have a good time. Goodbye.